Peter Buswell for drvoyp.com. The subject today is taking a look at the Ingate E-SBC session border controller in a virtualized environment. Ingate's done a really great job of taking their already superb product and making it available as a software solution, something that you can use to create a session border controller in a virtualized environment. Now, we have another presentation we did very recently. You can check it out. It's in the blog someplace, and it had to do with configuring a Dell firewall, a sonic firewall, in place of a session border controller in a ShoreTel SIP trunk configuration. Now, the question becomes one of, can you do that? And clearly you can. We did it. We showed you how to do it. But at the same time, we recommended that you don't do that. It's not a smart thing to do. You really do need to get a session border controller. Why do I need a session border controller? There's at least 5 good reasons, categories, that you need to become familiar with and get comfortable with. Again, I'll share a prejudice with you. I don't like firewalls used as SIP interfaces, session border controllers. I think firewalls need to do firewall stuff, and session border controllers need to do the session border controller stuff. So firewalls being deep packet inspection type of devices certainly can do many functions that you have in a session border controller, but does that make it a smart thing to do? So the true value of a session border controller, like the Ingate solution, is to address issues of security, connectivity, quality of service, media services, billing statistics, and even some regulatory functions. So from a security function, I like to think of the session border controller as the 66 block of the internet age. I mean, those people that have been kicking around the telephone industry are certainly familiar with this concept of a 66 punch down block, where you punch down the telephone company on one side, you punch down your equipment on the other side, and you put a bridging clip in the middle to separate the two sides. And that's how we established a point of demarcation in the physical world. So the question you have to ask yourself is, as you extend your telephone network out into the internet, how do you separate your network from the internet or from the carrier's network? Where's your 66 block? Where's your bridging clip? Well, that is a great reason to have a session border controller. You also want to be able to hide the topology of your network. Hacking and computer security and cyber crime are big issues today. And why make it any more easy for those folks to hack your network? We don't need to extend our private space out into the internet, and we don't need those folks to know what our private space looks like. We want to hide that. We want to provide a defense against malicious attacks. We need some tools for dealing with malformed packets, and we want to provide for encryption. We have TLS, we have IPsec, we want to provide media encryption. And so the session border controller works in a way to help bring security functions to the table in a way that, in my opinion, when we're talking about SIP voice and SIP video, it's done in a way that is very hard for a firewall alone to do that. Firewalls, session border controllers, sure, they provide connectivity. A firewall can do a NAT traversal, but is it really set up to do normalization? When you drill down on some of the differences in header messages between what ShoreTel might say in a SIP message on one side of the connection and what the carrier might say on the other, you'll find that you need an easy way to move these SIP messages around and to change the headers. And a session border controller will enable you to do that. We have to deal with IP to IP6 networking. We have to deal with VPN connectivity. And we have to provide protocol conversion, H323 to SIP and SIP to H323 and back. Quality of service issues, right? We want to police our traffic. We want to allocate our resources. We want to do rate limiting, call admission control, and deal with the class of service. Media services. Your firewall is not going to do media transcoding. Okay, it's not going to deal with DTMF relay and interworking. These are components that you need a dedicated media service function to handle. That's why we think you need to have a session border controller. Now, you're not going to meet anybody who's more of a Cisco brat than I am. But I will tell you that when it comes to a session border controller, you do want to take a hard look at the Ingate product. These folks eat, drink, sleep, SIP, and border controllers. They have an excellent product line, and not only do they have an excellent product line, but they have a body of intellectual resources that they make available to their clients through their support function, through their community, and through the ongoing educational process that they enable everywhere they go. When it comes to understanding SIP, these folks know it and are eager to have you understand it. So when it comes to a dedicated session border controller, you want to really seriously consider using this Ingate solution. What we're going to do here is, I'm going to have to break this into two parts because it's just going to be too long. In this first part, I just want to walk you through how to bring up the Ingate in a virtualized environment. We'll actually go through the process and bring up the Ingate SBC solution in an ESXi VMware box, and I'll show you how that's done. We'll do part two. We'll actually do a configuration and show you some of the configuration tools that Ingate has to assist your effort. We've done a video on the Ingate product before. Check it out. It's out there. It's very popular, and it does deal more with the configuration issues. This, I wanted you to just take a look at the VMware component. So they have a family of products, and typically the products are defined by the number of channels or simultaneous. In the SIP world, we refer to them as sessions, right? So let's give it the vocabulary. We're talking about a device that can handle 400 sessions. And it was tested by Ingate in the ESXi, which is a type 1 hypervisor from VMware, but it works on some other virtual solutions as well as the Linux-focused KVM, the VirtualBox, and I personally brought it up in VMware Workstation on a PC. So I have another video out there that you'll want to take a look at. It has to do with how to set up a VMware lab, because I'm going to use that same lab here in this presentation. You can also boot this ISO up on Intel compatible hardware. If it's supported, you don't have to bring it up in a VMware machine. You can just download the software, burn it as an ISO, and then boot it into the hardware panel. The licensing is pretty simple, but it's pretty strict. You can license one instance of SBC per box. So you'll go out to the Ingate site, and if you haven't already, you'll do a registration and get yourself an account. You'll need the account to get the software, number one, and number two, to get your license key. So let me walk you through the basic setup. Have you understand that it appears that the license code and the license key are two separate items, right? You're going to get your license code at the time you purchase your product, or you get that from the Ingate sales team, and then you're going to use that code when you go to the website and download the ISO software. It's going to ask you for your license code. Go ahead and put that in the box for that on the website. Then you're going to create a virtual machine. You're going to create your Ethernet ports, boot the ISO image into your, depending on how you're doing it, either into the VMware machine or the hardware, and you'll make a decision about installing SIParator or firewall, and we'll talk more about that. We have talked about it in previous blog videos, but basically you can configure the SIParator to be your firewall in addition to being the SIParator, or you can just have it be your SIParator if you already have a firewall. And again, I've cautioned everybody that listens to me, I strongly urge you to consider the benefits of having a SIParator on a separate public IP address that is the default gateway for your SIP devices, and let your data devices go out the firewall. Invariably, someone's going to do something to the firewall that will mess up the SIP functionality, and that's why I prefer to keep them separate. But you have the option here at the time to install it, in which you can do either model, SIParator or firewall. At the time you get that operational, you'll bring up a browser, surf to the SIParator, register the box. Again, it goes out to their site and registers it, at which time you get a license key, which you'll put in your software, and at that point you're licensing the software to the box you're running it on. The virtual configuration itself is not that demanding. It's as simple as a 1 gig disk drive. 6 gigs is just fine. Memory as low as 256 megabits of RAM. It's running on Linux 2.6, not 64-bit, and you will need two Ethernet ports, right? Clearly, you come in one port from the public and other port out to your internal private space for your SIP connectivity. So at this point, let's move from the boring slides over to the lab environment, and we'll take a look at actually configuring this software in an ESXi deployment. We have previously downloaded a copy of the ISO file from the Ingate website. So you'll go to the website, you'll log in, you'll get to a point at which you want to download the Ingate software. You want to go here where it says download software firewall SIParator, and go ahead and download it. At that point, it'll ask you to put in the license code. This is not the license key, it's the code that enables you to download the ISO. Depending on how that's configured, you can do it one time. And at that point, it'll be in your download. So I previously downloaded it here. This is it here. I'm very fond of checking the hash of my downloads. So if I go here and right-click on that file, get its properties, I have some code that checks the file hashes here. And when you downloaded this from the Ingate site, they told you, they showed you a screen and say, here's the MD5 and here's the SHA-1 fingerprint. So the reason you do this is, I don't know if you've ever thought about it, but here you are downloading an update to your Android or whatever. And how do you know that it's really the software that you think it is? Typically, the manufacturer will publish a hash fingerprint that you can then download your software and compare them. They should be the same. So we've got this guy downloaded. And at this point, we're going to configure an ESXi. We're going to create a new machine. So basically, we go new. We're going to create a virtual machine. We will just highlight our host, say new virtual machine. And at this point, we'll go ahead and declare this to be custom. And I'll caution you right here, if you select typical in an ESXi deployment, when it comes to the hard drive, it wants to install a SCSI device. And I discovered that if I did that, the ISO would not see that. And so by creating a custom device, I was able to select a different type of controller, and that solved that problem. So go with custom, give it a name. This is selecting the data store. On this, we only have one. I'll go ahead and do that. It's this is the compatibility with the different versions of ESXi. I'm going to keep it at version 8. We want to select Linux as the operating system. And as I pointed out during the slides, we'll go down here and select 2.6 Linux 32-bit. And at that point, we want to set the number of sockets. 1 is cool. Go ahead, gigabit size 1 is just fine. You don't need more than 1. It's very small footprint. How many NICs do you want? Well, we need to have 2 NIC cards, and we want them to be the E1000 flavor for compatibility. If you were to install this on hardware, that's what you would be required to have. And then go ahead, and here's where I was able to set up something a little different than would have been had I said typical environment. And we want to create a new virtual disk. Go ahead and create it. The default configuration is just fine. It doesn't have to be 16. It could be much smaller. In the lab environment, we're going to head and use thin provisioning rather than lay out 16 gig here. But the production model, you'd want to select the thick provisioning lazy 0. And we'll continue along here. Select now. What I found out was I don't want a SCSI device, I want an IDE device. And that made all the difference when I configured using the typical setup. You don't get the option to select the kind of virtual device node you want. So use custom and then select IDE. And at that point, what you're going to want to do is if you hit finish here, it's going to try and run. You want to select edit the virtual machine settings before completion and then go ahead and say continue. Now the reason you do that is because you may want to make some changes to the selections that you've made here. So you've configured your machine. Typically you're doing what might otherwise have been in an OVA file. But where we want to go is here to select the data store. Now is not a tutorial on VMware. I will tell you that you either have to put the ISO file in the client device and search for it that way, or you have to actually install it in the data store of your ESXi host. And so if you do that, then you can browse for it out there on your data store. Here's that file, and I'd go ahead and do that. And at that point, you also want to select Connected Power On. So when this box fires up, it's going to immediately connect and boot this ISO. All right. So at that point, we'll go ahead and finish. To power on the machine after you've created the configuration, just highlight the name of the machine, hit the green button, right click, power on. Either way will work just fine. Once the machine starts, you'll be in the console tab. You'll see it run through the pre-install options as it loads the ISO from the image that you connected, and then we'll start the actual hardware installation. It's going to ask if we want to proceed. Click inside the virtual machine or your keystrokes won't go there. We'll accept this. We want to install the SIParator. There's an option for SIParator and one for the firewall. We'll go forward with the non-persistent logging to RAM rather than persistent logging to a disk. And it's found our hard drive. It's asking, do we want to proceed, because it's going to erase everything. It'll ask us for an IP address. I have found that if you try to tab here, you're going to get in trouble, so hit the down arrow. Now we can tab over to OK. Password ABC123. I'm just joking. Don't tab, hit the down arrow. Now you can tab to OK. Do we want to proceed? Yes. Now I'll pause this in the interest of time unless there's something really interesting to show you. But it's going to go through a series of installation configuration options. This is all running off the ISO that we connected, and stay tuned. Okay, at this point the installation has completed successfully, and it's asking us to remove the installation CD from the machine so that it can reboot. So typically what we do is go over here to the machine, go to Edit Settings, and go to the CD-ROM drive. And at that point, we want to uncheck the Connected Power On, because what's going to happen is this thing will power on, and then once again it's going to reload the ISO image, and we'll be starting over again. And once again, the machine's going to restart. After the system reboots, after you've removed the ISO, you'll find yourself at a CLI login. You would log in using the credentials that you established during the original install, and you'll find a menu of options available. Keep in mind that this is a Linux appliance, and as is the case with many manufacturers, you will not have Linux root privileges. Therefore, your command set that you would normally expect to find as a Linux user are seriously abbreviated. Not having root privileges, you will have to execute only those parameters that the manufacturer gives you access to. So option 1 here, basic configuration, will allow you to revisit any of the options that we input during the initial installation, the IP address, set an IP address for the second interface. If you're going to the firewall mode, determine what IP addresses can access and administer this device and so forth. You can reset the password, reboot, do a factory reset. Option 7 here will get you to a command line interface. That interface, again, will only allow you to type these commands. So there are a list of utilities available to you to do basic troubleshooting, so you can ping and trace route and access some debug capabilities, the log, do a dump table, things like that. So at this point the SIParator is fully configured, and typically what you would do at this point is bring up a browser and go to the IP address of the SIParator, and you'll get to this login screen. You'll log in again using the credentials you input during the initial installation, and you will find that you can't do anything. There's no configuration options available at this point, because what you're going to need to do now is to log back into Ingate, give them the serial number, the installation ID, and the MAC address of this box, and at that point you will be able to download your license, browse, and install it into this appliance, and then we can set about configuring the SIParator. We'll do that, take a look at that in the second half of this video. At this point we have a fully deployed virtualized SIParator. I hope you have found this informative, and I thank you for viewing.